In this video, I want to show you how to apply chain rule to find the derivative of trigonometric functions. Before we start, let me remind you the chain rule. To apply chain rule to find the derivative of functions, first we identify inside and outside functions, and then we take the derivative of the outside function, leaving the inside function alone, and then we multiply it by the derivative of the inside function. For example, suppose we want to find the derivative of the function y equals sine of 2x. In this example, sine is the outside function and 2x is the inside function. Remember that derivative of sine is cosine. Derivative of sine of x equals cosine of x. To find the derivative of sine of 2x, first we take the derivative of the outside function. The outside function is sine, and the derivative of sine is cosine. So, the derivative of sine of 2x is cosine of 2x. Again, the derivative of sine of x is cosine of x. So, the derivative of sine of 2x is cosine of 2x. We leave the inside function alone. We don't touch the inside function. Times the derivative of inside function. The inside function is 2x, and the derivative of 2x is 2. So we multiply it by 2. And we can rewrite this answer in the form of 2 cosine of 2x. Another example. Y equals tangent of 3x. In this example, the outside function is tangent and the inside function is 3x. Remember that derivative of tangent equals secant squared. Derivative of tangent of x is secant squared of x. So derivative of tangent of 3x is secant squared of 3x. So derivative of the outside function, derivative of tangent is secant squared of 3x. We leave the inside function alone. Times derivative of the inside function. Derivative of 3x is 3. So derivative is 3 secant squared of 3x. Another example. We want to find the derivative of cotangent of pi theta. In this example, cotangent is the outside function and pi theta is the inside function. And remember that derivative of cotangent is negative cosecant squared, or derivative of cotangent of x is negative cosecant squared of x. So derivative of cotangent of pi theta is negative cosecant squared of pi theta. So derivative of outside function is negative cosecant squared of pi theta. Now we should multiply it by derivative of the inside function. The inside function is pi theta. Note that pi is a constant, is a coefficient for theta. Theta is the variable similar to x, and pi is the coefficient for theta. Compare it with 3x or 2x. Derivative of 2x is 2. Derivative of 3x is 3. Derivative of pi theta is just pi. And so derivative of this function is negative pi cosecant squared of pi theta. And note that instead of dy over dx, here I have written dy over d theta, because theta is the variable in this example. Usually the variable is x, but in this example the variable is theta. So instead of dy over dx, I have written dy over d theta, because the name of the variable is theta, and the y is the function. Another example, y equals secant of x over 2. In this example, secant is the outside function and x over 2 is the inside function. And remember that derivative of secant is secant times tan. Derivative of secant of x is secant of x times tangent of x. So derivative of secant of x over 2, derivative of the outside function, secant of x over 2 is secant of x over 2 times tangent of x over 2. So derivative of the outside function is secant of x over 2 times tangent of x over 2. Now is the time to multiply it by derivative of the inside function. What is the derivative of x over 2? You don't need to use quotient rule. You can consider x over 2 in your head as 1/2 times x. So derivative of x over 2 is 1/2. Derivative of x is 1, so derivative of x over 2 is 1 over 2, or 1/2. And so derivative of the function equals 1/2 secant of x over 2 times tangent of x over 2. Another example. We are asked to find the derivative of the function y equals sine to the third of x. Anytime you have something like this, what that means is sine of x all to the third. In this new form, more easily you can identify the outside and inside function. The outside function is to the third, and the inside function is sine of x. To find the derivative of the outside function, we use power rule. We bring the power down to the front of the term as a coefficient, and we reduce power by 1. So the derivative of the outside function is 3 sine of x all squared. Now we multiply it by derivative of the inside function. Remember that derivative of sine of x is cosine of x. And this is the derivative of the function. And if you want, you can rewrite it as 3 sine squared of x times cosine of x. Another example. Y equals secant squared of x. First I write it in the power form. Now secant of x is the inside and squared is the outside function. Derivative of the outside function is 2 secant of x to the 1. Note that we bring the power down to the front of the term as a coefficient and we reduce power by 1. So derivative of the outside function is 2 secant of x to the 1 times derivative of the inside function. Remember that derivative of secant of x is secant of x times tangent of x. So derivative of the inside function is secant of x times tangent of x, and we can simplify it as 2 secant squared of x times tangent of x. Secant times secant is secant squared. Another example. Y equals cosine to the fifth of 2x. First I write the function in the power form. Cosine of 2x all to the fifth. The outside function is to the fifth and the inside function is cosine of 2x. We use chain rule to find the derivative of this function. First we take the derivative of the outside function. The outside function is to the fifth. We bring the power down to the front of the term as a coefficient and we reduce power by 1. So the derivative of the outside function is 5 cosine of 2x to the fourth. Now is the time to multiply it by derivative of the inside function. To find the derivative of the inside function, again we need the chain rule. Cosine is the outside and 2x is the inside function. The derivative of cosine is negative sine. We leave the inside alone. We don't touch it. We just write the inside function. Just we take the derivative of the outside. Derivative of cosine is negative sine. Derivative of cosine of 2x is negative sine of 2x. Times derivative of inside. Derivative of 2x is 2. So derivative of the inside function is negative sine of 2x times 2. And this is the derivative of the function. If you want, you can simplify your answer and write it as negative 10 sine of 2x cosine to the fourth of 2x. Note that negative times 2 times 5 is negative 10. Another example. Y equals sine of cosine of x plus sine of square root of x. To find the derivative of sine of cosine of x, we use chain rule. Cosine of x is the inside and sine is the outside function. Derivative of the outside function, derivative of sine is cosine. So derivative of the function is cosine of, we leave the inside function alone. We take derivative of outside. The outside function is sine. Derivative of sine is cosine. And we leave the inside function alone. We don't touch the inside function. So cosine of x. Let's review it again. To find the derivative of sine of cosine of x, we take the derivative of the outside first. The outside part is sine. Then the derivative of sine is cosine. And we leave the inside function alone. We don't change the inside. Times the derivative of the inside function. The inside function is cosine of x. The derivative of cosine of x is negative sine of x. Now we should find the derivative of sine of square root of x. Square root of x is the inside and sine is the outside function. First we take the derivative of the outside function. Derivative of sine is cosine, and we leave the inside function alone. So derivative of sine of square root of x is cosine square root of x times derivative of the inside. Derivative of square root of x is 1/2 x to the negative 1/2. Remember that we can rewrite square root of x as x to the 1/2 and bring the power down to the front and reduce power by 1. So derivative of square root of x is 1/2 x to the negative 1/2. Derivative of the inside function is 1/2 x to the negative 1/2. And this is the derivative of the function. If you want, you can rewrite x to the negative 1/2 in the radical form with this formula. Any expression to the negative 1/2 is 1 over square root of that expression. So x to the negative 1/2 is 1 over square root of x. So we can rewrite our answer in this form. Negative sine of x times cosine of x plus cosine of square root of x times 1/2. Instead of x to the negative 1/2, we put square root of x in denominator. If you want, you can rewrite this as negative sine of x cosine of x plus cosine square root of x over 2 square root of x.